Hello, my name is Nikita, and I am a junior civil engineering major at Brooklyn Tech. On the Conrad Challenge, I work on the construction of the website, the creative design, and the construction research.
Hi, my name is Vihan Agnihothri, and I'm a student at Jericho Senior High School with a strong interest in environmental science and a future goal of pursuing a business major. For the Conrad Challenge, I worked mostly on the brief and focused on project management and integrating sustainable practices to ensure that the solution was both practical and impactful.
Hello, my name is Solomon Tartakovsky. I am a junior at Brooklyn Technical High School, and I am in the software engineering major. For the Conrad Challenge, I worked on doing the research behind the AI model, writing the code for the AI model, and working on the website and the brief.
My name is Ars Prowitz. I go to Brooklyn Technical High School. I'm in the software engineering major. So for this Conrad Challenge, I mostly developed the computational plan. I worked on the model development, and I also did research for the model, and I also worked on the brief.
Hello, my name is Nathan Yallen. I go to Brooklyn Technical High School and I'm in the finance major. For this Conrad project, I helped develop the business plan, the marketing plan, and I make most of the website.
Since the 1950s, carbon emissions have been identified as the primary reason for ecological damage on our planet. Many have attempted to stand against the rising issue, but only few were successful. The most well-known contributor to carbon emissions is, of course, fossil fuels, such as coal and oil. However, many are not aware of a devastating contributor to the death of our planet. Construction accounts for over 1/3 of the world's carbon emissions.
One big part of the energy efficiency crisis is buildings. The issue with buildings is that they are not efficient enough, and the current strategies to make them more efficient are failing. I'm sure many of you have walked by your buildings and seen signs that say a D in energy efficiency on the side. However, this doesn't just simply mean they're failing in energy efficiency, it also means they're failing the people that live in them, as higher failure to comply with energy efficiency standards means higher costs for buildings and for families around the country. In order to combat rising energy efficiency problems and rising costs for buildings, we have decided to create a solution that will utilize a dual AI model to help generate energy efficient buildings, which will reduce the costs for families, construction companies, and help improve our planet. We present to you Ecostruct.
With the urgent threat of climate change, we aim to create a solution that can be implemented on a large scale to cut carbon emissions. We aim to create a program that can effectively target one of the key contributors to carbon emissions rather than a side effect to ensure an overall decrease in climate change. Our solution will be able to not only decrease the amount of carbon emitted, but also directly lower prices in order to make our solution more enticing to companies and make homes more affordable to families. By constructing buildings more effectively, we hope to utilize fewer materials and cut the cost it takes to operate them, decreasing the catastrophic cost that has families choosing between keeping the light on and paying the rent.
We start with the latent vector that holds the user's constraints for the initial building, which is fed into our generator model where the iterative optimization process starts to produce a proposed building design. The design is passed to the evaluator model, which predicts how much energy the building might consume. We convert this prediction into a reward calculation, where lower energy translates into higher reward. Then, using generalized advantage estimation, GAE, we measure how much better or worse the design is than expected. And the PPO loss function nudges the generator's parameters to preferred designs with higher rewards. The PPO loss specifically clips overly large changes in the generator's parameters, keeping improvements steady and stable. The iterative process, constraints in, design out, and energy checked, continues until the system's predicted energy usage plateaus, yielding our final optimized building design containing the energy and the cost.
Based on our program, we have been able to develop a business model that can spread this technology around the globe. Primary customers are construction companies, architects, and homeowners, with construction companies as the main buyers.
We focus on construction companies because they drive projects, face pressure to meet sustainability standards, and also need to cut costs. Our tool will help them to design energy-efficient buildings, save on operational expenses, and stay competitive in the $15 trillion global construction market.
Our SaaS model offers subscription tiers, from standard packages for smaller firms to enterprise-level solutions for large-scale projects. Licensing agreements add another revenue stream.